Hi, it's Mark Marmer from Signature Electric. So I am here with Mabel Fulford, our friend from Peak Power.
It's wonderful to have you here. This is actually the Thompson building. The family office of David Thompson Osmington is one of the investors in Peak, and they graciously have enabled us to use this site as a demonstration site. So this battery behind us was actually the first battery that Peak ever installed. And since then, we've got IoT sensors in the building. And as you can see, we've also got this bidirectional vehicle charger here. And so this demonstration site gives us an opportunity to demonstrate how they all work in concert with each other. And so we can operate them as a whole to balance out, building energy demands, battery storage, and electric vehicle charging. And really that gave us an opportunity to show we can do it at one site. This is the virtual power plant concept, that we can aggregate buildings, batteries, and vehicles across any number of different locations. And so that's what we do today. Peak Drive and bidirectional charging is still in demonstration phase, but today we've got our Synergy software operational in a number of buildings with batteries. Basically, the goal here is to provide energy management and look at when is power most needed by the grid. So in most of North America, our electricity grids are under the most strain when we've got the most demand, which usually is extreme weather. Sometimes when it gets really cold and everyone's got their heating on, but most often it's those hottest days of the year when everybody has their air conditioning running on max. And so it's really expensive to operate the system to meet those demands. And a much more cost-effective way with these new technologies using software such as Peak Powers is to actually use these distributed energy resources. Battery energy storage, you can kind of imagine how that works, just like a normal battery. You can put power in when it's available, and you can discharge power out when, for example, there are electricity savings to do so. We have our algorithms and AI technology that allows us to forecast when those moments of peak demand are going to occur on the grid. And we have an operations platform that aggregates all the different batteries, buildings, and vehicles that we have across all of our customer sites. Whether that's Ontario, we also operate a number of US markets. That enables greenhouse gas reductions because those moments of peak demand tend to be when we have the most polluting sources of energy on the grid. It also generates real dollars. So buildings, especially large commercial and industrial buildings, more than 2/3 of their energy bill can come from their power consumption in just 5 top hours in the year. Peak is able to come in with let's say a battery system and operating using our software so that the battery basically reduces the energy bills of the site. And so, for example, we might charge the batteries up overnight and then use them to power the building during the day when electricity is more expensive, and particularly for those really high cost events with the peak power demands. That's where the batteries come in. But similarly, buildings can act like batteries. And so that's where the IoT, Internet of Things sensors come in. It allows us to say, buildings' first priority is always the comfort of their tenants and operations. But there are a number of choices that can be made which can shift the energy profile and energy demand of a site. So for example, on a day where we're expecting a peak event to happen, Peak software can predict that that's going to occur and enable the building to react. So for example, perhaps they might shift cooling to earlier in the day, or perhaps there are things that can be done to reduce the power demand, particularly in those peak hours, to generate those savings. And so, we sometimes we like to use the phrase synthetic battery, but a building can act in the same way, where you can change the way that the demand profile works by saying, let's pull more power earlier and less power later. And that's the same thing as if you had dispatched from a battery to meet those building demands. So for example, Peak Power, we have battery projects and distributed energy resources in a whole bunch of different buildings for different customers in different places, but they can be operated as a whole. And so we're working on a number of innovation projects right now to look at how can you aggregate those resources and enable them to participate in the grid and in electricity markets the same way as power plants do. So there's no reason with the software and technology we have today that these aggregations of distributed small energy resources can compete against major power plants. They can provide the same value. We're working on a number of projects with the Ontario's Independent Electricity System Operator, the IESO, to look at exactly that. With virtual power plants and distributed energy resource aggregation, what does that look like? What does a system look like where individuals can participate in electricity markets to facilitate these types of projects?
Again, I always point out that here we are in Toronto and we have this innovative Canadian company. And I know that when I was speaking to Imran the last time, he goes, we seem to be better known outside of Toronto and other places. So do we have this kind of uptake in other places outside of Canada at the moment?
Absolutely. So we operate in a number of regions in the US as well. They all have slightly different regulations, slightly different electricity systems. But actually in the US, there's a federal regulation called FERC Order 2222, which is making really big changes. It basically is going to mean that all federal electricity markets in the US are going to be required to allow these distributed energy resources, so that means vehicles, batteries, and buildings, to participate in the grid and participate in energy markets. So that really does mean, for example, participating in a capacity auction against some of these conventional generators. And they're doing that through aggregation. And so that's really exciting. That's really what we're working towards as a company, where we can enable some of these aspects today. And we know that it's going to become accessible to a much wider range of businesses, buildings, of individuals, as our regulatory systems and as our energy policies evolve.
Something really interesting happening. Literally, I'm across the street from the City Hall, right here in Toronto, right in our own backyard. I'm just thrilled for this connection to be part of some of these installations, not this particular one, but we have been part of other installations. We've got projects moving forward. I think when I speak to you, I get the same kind of peak energy from everybody's very excited about what they're doing, and that makes it fun for us and I think our viewers and listeners as well. Mabel, thank you so much for coming down to this lovely garage with me. As the projects unfold, we'll get together and do this again.
Absolutely. I'm looking forward to it, and we're delighted to be working with Signature Electric, and hopefully we'll have many more of these to come.
Fantastic. I invite you to look on our website and see more of this. We've got already a little bit more, several different things that are with Peak Power. We always want to have something interesting, show you kind of a peek into where we think things are going, and I do believe we're right on the right track. Other companies are doing this too. When I see something like the Ford F-150 Lightning and people talk about power to the home, this has got people excited. If you're looking for more of this, you can find it on our website, signatureelectric.ca. You're welcome to call us if you want, 416-490-8093. Our YouTube channel, youtube.com/signatureelectric. Lots of ways to find us. Again, thanks very much, Mabel.